Hello everyone, welcome to Neso Academy. In the previous lecture, we learned constant variables. We learned that named constant has multiple types and one of the types is the constant variable. Now in this lecture, we will discuss the second type of constant variable, which is the macro. So the name of this lecture is Macros in C++. So without any further delay, let's get started with this lecture and let's see what are the topics of this lecture. The first topic is Introduction to Macros. First, I will introduce you to macros. Then we will move to the next topic where we will learn object-like macros. After completion of the second topic, we will move to the third topic where we will understand function-like macros. And lastly, we will learn problems with macros. So these are all the topics which we will learn in this lecture. So let's get started with the first topic, that is Introduction to Macros. We learned constant variables in the last lecture. We are done with this topic. Now we are moving towards macros. Let's understand this type of named constant. A macro is a name which preprocessor replaces with a value or a code before compilation. So macro is a name which is replaced by the preprocessor. It has nothing to do with compiler. Preprocessor is the processor which processes before compilation begins. This is what we learned before as well. We know the role of preprocessor, and preprocessor is responsible to handle macros as well. A macro is a name which is handled by the preprocessor. Preprocessor replaces the macro with its actual definition. It can be a value, it can be a code. It depends on the definition of the macro. But it is all done before the compilation. So I hope the definition of the macro is clear to you. Macro is a name which preprocessor replaces with a value or a code, that too before compilation. It is defined with the help of hash define directive. This is the preprocessor directive, just like hash include. With the help of hash include, we can include the header file in the program. With the help of hash define, we can instruct the preprocessor to define the macro in the code. So with this, I hope it is clear what is the meaning of macro and how macro is handled. Now, there are many different types of macros, but in this lecture, we will understand only two main types of macros. Let's see what are those two types. The first one is object-like macros, and the second one is function-like macros. These are the two types which we will discuss in this lecture in the subsequent topics. Now we have understood what a macro is, how to define a macro, and what are the two main types of macros. So now we are done with the first topic, that is Introduction to Macros. Let's move to the next topic where we will understand object-like macros. So what is an object-like macro? An object-like macro is used to define a fixed value in the code. Object-like macro is a macro. This means it has a name. It is the name which is used to define a fixed value or a constant in the program, just like a constant variable. We learned about the constant variables. We have object-like macros which are similar to constant-like variables. There is the syntactical difference, but they both can define the constants in the program. They are called object-like macros because they look like objects, just like constant variables. And it is replaced by the defined value whenever encountered. So whenever preprocessor encounters an object-like macro, it will be replaced by its defined value. I have told you already that preprocessor handles macros. So clearly, this type of macro will also be handled by the preprocessor. So with this, we have understood what is an object-like macro. We understood these 3 points. Now let's understand through an example how to define the object-like macro in C++ program. Here is the C++ program. In this program, I have included the IOStream header file. This I have included with the help of this hash include directive. IOStream is included because here I'm using the cout object. This is available in the IOStream header file. After this, I have defined this pi constant. This is the macro. And this macro has this value 3.14159. It looks like an object only, that is why it is called an object-like macro. I hope it is clear to you. And here it is used to define this fixed value 3.14159. This is what I have mentioned here. Object-like macro is used to define a fixed value. I am doing the same thing. Now, in this main function, I am using this cout to print the value of pi. We know that preprocessor has to handle the macro. Compiler has to do nothing with this pi. This pi will be replaced by its defined value. This is what I have written here. It is replaced by the defined value whenever encountered. Preprocessor has encountered pi, so it will be replaced by its defined value, which is 3.14159. So here I can write 3.14159. And this is done by the preprocessor. It has nothing to do with the compiler. Please remember this. Now, when we execute this program, we will get this output 3.14159. So with this, I hope it is clear how to define the object-like macro in a program. So with this, we have learned this topic also, that is object-like macros. Now let's move to the third topic, where we will understand function-like macros. So what are function-like macros? A function-like macro is used to define a code like a function. It is called function-like macro because it looks like a function and it is used to define a code in the program. So with the help of function-like macro, we can define a piece of code in the program and preprocessor will replace that function-like object with the defined code. This is the second point. It is replaced by the defined code whenever encountered by the preprocessor. Now let's understand how to define function-like macro in a program. Here, in this C++ program, I have included IOStream, and after this, I have defined this macro. This is the function-like macro, and here I have used hash define for this purpose. We know this already. For defining a macro, we need to use hash define. We use the same hash define to define the object-like macro as well. Now we are using it for the purpose of defining function-like macro. This looks like a function, that's why it is called function-like macro, and it is used to define this code A times B. Here the name of this macro is mul and the inputs provided are A and B. The code is A times B. So clearly, mul A comma B is same as A times B. So this macro is defined. Now after this, I have defined this main function. And within this main function, I am using cout to print the result of mul 3, 4. As preprocessor encounters this specific function-like macro, it will be replaced by 3 times 4. Why I am saying 3 times 4? Because mul A comma B is same as A times B. So clearly mul 3 comma 4 is same as 3 times 4. So it will be replaced by 3 times 4, that too by the preprocessor. Compiler will see this expression. It has nothing to do with the macro, but it will see the final expression, which is 3 times 4. Now this will be evaluated and we will get 12 as the result. With the help of cout, we will get 12 as the result on the screen. So with this, I hope it is clear how to define function-like macro in a C++ program. We call it function like macro because it looks like a function. We can define a kind of a function with the help of function like macro, but it is not the function. This macro represents A times B. So, preprocessor will replace this macro by A times B. In place of A and B, we may have values like 3 and 4. So I hope this idea is clear to you. Now you may be thinking that if we can define function like macros, then why do we need functions? We know exactly what a function is. A function represents a piece of code which can then execute to produce some output. But if we have these function like macros, then why do we need functions? Function like macros are good to define single line functions. That is, if we want to define single line codes, then we can use these function like macros. But to define complex pieces of code, we need to use functions. It is not suitable to define multi-line codes with the help of function like macros because it makes the code less readable. So, if we want to define single line functions, then we will use function like macros. But there is one important point we need to understand now. In modern C++, function like macros and object like macros are highly disregarded. There are several reasons behind this, and we will understand some of the reasons in the next topic. But for now, we have understood function like macros properly. So we are done with this topic also, that is function like macros. Now let's move to the fourth topic, that is problems with macros. Now let's understand what are some of the problems associated with macros. The first problem is global scope. If a macro name is used somewhere which should not be replaced, then it may cause compilation error. It is important to understand that a macro has the global scope. By global scope, I mean that a macro is visible to the entire program, even if it is defined within a function. It does not matter where we define the macro is available to the entire program. The entire program can see that macro and use it. Now there is the problem with the global scope. If we try to define the constant variable with the same name as the macro name, then we may get the compilation error in the code. This is because the macro is available to the entire code and it is visible to the complete code. Due to this reason, we cannot use the same name to define, let's say, the constant variable. This is what I have written here. If a macro name is used somewhere which should not be replaced, just like a constant variable, then it may cause compilation error. To understand this statement properly, let's take one C++ program. Here I took this example. I have included the IOStream header file because I am using cout here. I have defined this function SumFun. This is the name of the function. Here we have these parentheses. These parentheses indicate that I have defined this function. The return type of this function is void. This means this function will not return any output. And within parentheses, there is no input. Therefore, this function will not receive any input. But it will do some work. Here, I have defined the size macro. This is the object like macro, and it has the value 100. I have defined this within this function. And I can say this that I have defined this within this function because this is available within these braces. So this is the function definition. I have defined this macro within this function. Normally, when we define a variable within a function, then that variable has the local scope. This means that variable is visible only within that function. The variable normally does not have the global scope. But the macro has the global scope, no matter whether it is the function like macro or object like macro. It has the global scope. So this macro has the global scope. So it is visible to all the functions which we define in this code. Here I have defined this main function. In this main function also, this macro is visible. Here I am calling this some fun function to execute this function. After this, I have defined this constant variable size. I am using the same macro name to define this constant variable, and the value of this constant variable is 10. This is not allowed. This is because this macro name cannot be used in this code. This macro name is visible to the entire program. We cannot use the same name here to define this constant variable. This is what I have mentioned here. If a macro name is used somewhere which should not be replaced, then it may cause compilation error. We know that preprocessor will handle the macro. So this size will be replaced by 100 by the preprocessor. This does not make sense. We cannot have the name as 100 for the constant variable. Therefore, we will get compilation error from here. We need to understand this, that this specific macro has the global scope and this will be replaced by the preprocessor with value 100. This does not make sense to the compiler, hence compiler will give us the compilation error on the screen. I hope this idea is completely clear to you. So, this is the biggest problem with a macro. If we use a macro in the code, then it has the global scope. We cannot use the same name of the macro anywhere in the code. And it is quite difficult to find the source of the error in the code as well. Due to this reason, macros are disregarded in modern C++. So with this, we have understood the first problem that is faced when we use macros in the code. Now let's move to the second problem. The second problem is hard to debug. Macros are hard to debug, and by debug I mean finding errors in the code. It is difficult to find errors in the code because of macros. Let's try to understand why it is difficult. Here I have written preprocessor handle macros and hence the code may produce incorrect results without compilation error. We know preprocessor handle macros. Hence, there is the possibility that if the code produces incorrect results, then we will not get compilation error. Even though we are getting the incorrect result, but we may not get the compilation error because compiler has to do nothing with the macro. Macro is handled by the preprocessor. Now let's try to understand why it is hard to debug a specific macro with the help of an example program. Here I took the same macro mul a comma b with this code a times b. This is the function-like macro. We know this already. I have included the IOStream as well. And here I have defined the main function. In this main function, after cout and these two less than symbols, I have specified mul 3 plus 2, 4 minus 2. In place of simple values, I have provided these expressions 3 plus 2, 4 minus 2. It is perfectly valid in C++. Now, we may think that 3 plus 2 will be evaluated and 4 minus 2 will be evaluated. We will get 5 here and 2 here. This means we are using mul 5, 2. Preprocessor will replace mul 5, 2 by 5 times 2. Compiler will evaluate 5 times 2 and we will get 10 on the screen. We may expect 10 on the screen, but after execution of this code, we will get 9. Clearly, we are getting the wrong answer. We are getting 9, but we were expecting 10. We are getting the incorrect result and we are also not getting any compilation error because compiler has to do nothing with this macro. This will be replaced by the preprocessor. Eventually, we will get the expression, compiler will see the expression and that expression will be evaluated. We will get 9 as the result, but we are not getting the compilation error. And due to this reason, debugging this code is quite difficult. We don't know what is the cause of the error. Now let's try to understand why are we getting the wrong answer. Let's replace this mul 3 plus 2, 4 minus 2 with its expression. We know that in place of A we have 3 plus 2. In place of B we have 4 minus 2. Preprocessor has the job of replacing the specific macro with its actual definition, be it code or a value. Here we have the function like object. This will be replaced by this code. So, in place of A, we will get 3 plus 2, and in place of B, we will get 4 minus 2. Preprocessor will only replace, it will not evaluate anything. So here we will get 3 plus 2 times 4 minus 2. No evaluation, only replacement by the preprocessor. Now what happens? We know the basic math rules. We know that multiplication will happen before addition and subtraction. Therefore, 2 times 4 will be evaluated first. 2 times 4 will give us 8. So we will get 8 here. 3 plus 8 minus 2 is 9. This will be evaluated left to right. 3 plus 8 will give us 11, and 11 minus 2 is 9. That is why we are seeing this output 9 on the screen. I hope now it is clear to you why are we getting this output. The reason is clear. Preprocessor does not evaluate an expression, it just replaces the function like macro with its actual definition. This is the job of the preprocessor. We know we have this expression. We want to evaluate these two expressions first. This means we want to perform the addition and subtraction first before multiplication. For this purpose, we need to put these expressions within parentheses. And in order to do this, we need to parenthesize A and B here. Then only we will get the correct result on the screen. Here, 3 plus 2 and 4 minus 2 will be evaluated first. 3 plus 2 will give us 5 and 4 minus 2 will give us 2. 5 times 2 is 10. So we will get 10 on the screen for this specific program. So in this way, we have debugged the code. But for a beginner, it is not easy to debug such type of code. This is the reason why if we use macro in the code, it is quite hard to debug the code. In modern C++, we have various other methods in place of using macros. We have better alternatives to macros. We can use inline functions in place of these function-like macros. In place of object-like macros, we can use constant variables. So with this, we have learned the problems associated with macros, and now we know why macros are disregarded in modern C++. This means we are done with the last topic as well, and we are done with this lecture. Okay friends, this is it for now. Thank you for watching this presentation. I will see you in the next one.